Hi, Math 2. This is page 61 of our workbook. It's lesson 8. It's still on parabolas. And so let's take a look at 8.1. 8.1 says that this is a parabola with a focus at -2, 2 and a directrix at y equals 0, and A, B, and C are on the parabola. So let's see the question that they're asking us. It says, without using the Pythagorean theorem or the distance formula, find the distance from each point to the parabola's focus. So remember, the big takeaway from lesson 7 was that a point on a parabola is equal distant to the focus and the directrix. So the directrix is usually easy. We just count our spaces. So right here is our y equals 0, which is the x-axis, and this is our directrix. So for example, A is 1, 2, 3, 4, 5 units, 5 units above my directrix. It's got a distance of 5. So I actually know then the distance between A and the focus has to be 5 as well. I don't need the distance formula or the Pythagorean theorem to find that. So I know that the distance between the focus and A, so the focus to A would be 5 units. So why don't you find the distance from the focus to B and the focus to C? So the focus to B was, it's 10 units from B to the directrix, so it must be 10 units from B to the focus. And finally, C is y units above the directrix, because the distance above the x-axis is going to be my y value. So then I know it's y units from the focus, whatever that coordinate is. So let's take a look at the next page. Hi, Math 2. This is Unit 6, Lesson 8 on parabolas, and page 61 of our workbook. So on this page, it's showing us a parabola with a focus at -2, 2, and the directrix is the line y equals 0, which is the x-axis. It's in blue. And points A, B, and C are points on our parabola. So what does it ask us? It says right here, without using the Pythagorean theorem, find the distance from each plotted point to the parabola's focus and explain your reasoning. Well, let's remember the big takeaway from lesson 7. Each point on the parabola is equal distant to the focus and the directrix. So taking a look at point A right here, it is the same distance from A to the directrix as it is from A to the focus. So I can find the distance from A to the directrix really easily, 1, 2, 3, 4, 5 units, or I'm looking at the y value since it was the x-axis, y equals 0. So this is 5 units in length. So I know the distance between 2, 5 and this -2, 2 is also going to be then 5 units. If A is on my parabola, it's equal distance to the focus and the directrix. So the distance from the focus to A would be 5 units. So let's look at the distance from the focus to B, and then from the focus to C. So I realize that B is 10 units above the x-axis, 10 units above my directrix. So then I know that it's also going to be 10 units away from the focus. So I know that this is also going to be 10 units. So what if I don't know what my y value is? Well, I still know that it's y units above my directrix. So then I still know whatever that value is, it's y units away from my focus. So the distance from the focus to a point is the same as the distance from the point to the directrix. And we're going to use that on the next page to establish a new formula, a new equation, the equation of a parabola. So let's take a look at this page. So at the top of our page, I'd like you to write down a really important equation. This equation is going to be x minus a squared plus y minus b squared equals y minus k squared, where my focus is AB. That's where I'm getting those two numbers. And y equals k is my directrix. So this equation is on our formula sheet. If you've not found that yet, our formula sheet for Unit 6 is in the locker, and I do think you should print it if you can, or write the important formulas on a separate sheet of paper so they're just handy and easy for you to find. So things like the slope formula, which we'll be using in lessons 9 through 14, and this formula for a circle, which we used in lessons 4 through 6. Those sorts of things are on our formula sheet, and they're really helpful. So let's take a look at this problem. It says the image shows a parabola with focus at 3, 2 and directrix y equals 0. So remember, our focus is our A, B, and our directrix is our y equals k for our formula. So let's take a look at number 1. It says write an equation that would allow you to test whether a particular point is on the parabola. And I'll come back to that in a moment. Let's start by writing the equation of our parabola. So I use the equation I'm given above, and it was x minus a. So in this case, my a is 3, so it's x minus 3. Remember, it looks the opposite because of the minus sign. Plus y minus b, our b was 2, so I'm going to put in a 2, equals y minus k. Our k is 0 in this case. So a lot of people realize that y minus 0 is just y. So it's okay to write it this way. It's also okay to write it as just a y squared. Since y minus 0 is y, some people will write it this way. So sorry about that. I think I added an extra line. Let me erase that. So I now want to take us back to an important aspect of algebra for just a moment. When you have an equation, whether it's the equation of a line or the equation of a circle, or in this case, an equation of a parabola, in order for a point x, y to be on my equation, it has to, or be on my parabola, it has to make the equation true. When I plug it in, it has to make the equation true. So for example, I don't know if this point 5, 2 is on my parabola, but a very important side skill, so this is a side note, a very important side note to understand is if 5, 2 is on my parabola, it will make the equation true. So let's test it. To test a point, in this case, our point's going to be 5, 2. I mean, it looks like it's on the parabola, but to test it, I will plug it into the parabola's equation. So my x-coordinate is the 5, so I'm going to put a 5 in, minus 3, I'm really just using this exact same equation, squared, plus y is 2 in this case, 2 minus 2 squared equals, and then my y is 2 squared. So all I did is take my blue equation or the black equation, doesn't matter, and I plugged in 5, 2. 5 for x and a 2 for y. If this point is on the equation, it will make this true. So let's check this out. I'm going to erase my arrow that I drew, though, because it's in the way of where I want to write next. So over here, I would get 2 squared. 5 minus 3 is 2 squared, plus 0 squared equals 2 squared. You can already see it works. You get 4 equals 4. That's true. So I know that 5, 2 is definitely on my parabola. So this is going to come up in our homework problems for the next several lessons. They're going to want you to see if a point is on the line, or if a point's on the circle, or if a point's on a parabola. And you've got to be able to test that in the equation. Okay, so let's go on with our notes today. Number 2, it says the equation you wrote defines a parabola, but it's not a very easy to read form. Rewrite the equation to be in vertex form, where HK is the vertex. So I'm now going to solve my blue equation for y. So this problem, let me write the equation. Rewrite it here, x minus 3 squared plus y minus 2 squared equals y squared. I'm going to solve this equation for y. I want it to look like y equals a times x minus h squared plus k. So first of all, step 1, leave x alone. Leave x alone. You don't want to mess with my x minus 3 squared term. Why? So if I could get my yellow highlighter here, notice that in the equation, there's an x minus something squared term. It's right there highlighted in yellow. That's what this is to me. Let me highlight him in yellow. So I'm going to leave him alone. He's good. I like that binomial. What I don't want, though, however, is the y minus 2 squared. So I'm going to multiply out. So step 2, let me change my color. So step 2 is I'm going to multiply the y terms with either the box method or FOIL. It depends on which method you like to use. I'm going to show box method. So y minus 2 squared. So remember, you would do your y and your minus 2 horizontally and then vertically. You create your box, 2 by 2 box. And my y times y is y squared. My negative 2 times y is negative 2y. My y times negative 2 again is negative 2y. And negative 2 times negative 2 is 4. So this would be y squared minus 4y plus 4. So my next line would look like x minus 3 squared. I'm going to leave that term alone. And now I've multiplied this out, and I've got y squared minus 4y plus 4 equals y squared. So at this point, my next step, so step 3, I'll do it in another color. Step 3 is to solve for y. So usually this involves several steps. The first step is my y squareds. I can subtract y squared from both sides and they would cancel each other out. So let's go ahead and do that. Then I'm left with x minus 3 squared minus 4y plus 4 equals 0. So at this point, you can either move your y terms to the right side of the equation to isolate them, or you can move everything else to the right side of the equation away from the y. I think there's fewer steps, and it's a little easier to move my y to the right side. So I'm going to add 4y to both sides. What I'm doing is I'm trying to isolate the y term. So on the left side, I have x minus 3 squared plus 4 equals 4y. So I don't have y isolated yet. I have 4 times y. So I'm going to do the opposite and divide this by 4. When you do that, so you don't make an algebra error, divide every single other term by 4. So I'm going to draw a line and divide this by 4 and draw a line and divide this by 4. Divide every single term by 4 so you don't make any errors. So the 4's cancel and I get y. My 4's cancel and I get a 1, not 0, careful. And in mathematics, we don't write x minus 3 squared divided by a 4. Instead, we multiply it by the reciprocal. So the reciprocal of 4 would be 1 over 4. So I would write that as 1/4 times x minus 3 squared. And then this is me solving for my y. And if you look at the original equation in this equation, this is my y equals a, which is 1/4, times x minus 3 squared plus 1, which is my k. So I'm going to do this type of problem with you guys again in case you had any questions following along. Let's try it one more time. So let's go to the next page and use some of the space there to try another problem. So on this page, let's try another problem. This problem, the focus of my parabola is going to be -1, -7, and my directrix is going to be y equals 3. So I'm going to use my equation that we wrote at the top of the last page. It was x minus a squared plus y minus b squared equals y minus k squared. Remember that my focus was my AB and my directrix was my y equals k. So to write my equation, I would get x minus a -1 squared, that's x minus my a, plus y minus a -7 squared equals y, in this case, minus 3 squared. You'll notice last time it was a 0, so it kind of went away. This time it's not, so I have y minus 3 squared. A negative is a positive, so I'm going to take care of that first. It's really y plus 1 and y plus 7. So using my steps from the other page, my first step is I'm going to leave the x plus 1 squared term alone. I'm going to now do step 2. Step 2 says to multiply out my y terms. So out to the side, that's my y plus 7 times my y plus 7. I create my box and I do my math. And I will create my y minus 3 box and my y minus 3. And I will do my math. So for my next line, I left my x term alone. I multiplied this term out. Inside your box, you should have got y plus y squared plus 14y plus 49 equals y squared minus 6y plus 9. So now, just like on the last page, I have to solve for y. My first step, if I subtract y squared from both sides, they cancel. So let's do that. So now this has a little bit more algebra going on. So I'm first going to move my y over. So I'm going to move my 14y over by subtracting it. And it cancels. So I get x plus 1 squared plus, looks like just a 49 because the 14y is canceled, equals -20y plus 9. So now I'm still trying to isolate my y value. So now I'm going to subtract 9 to get it away from my y term. And it looks like I get x plus 1 squared plus 40 equals -20y. And so now, again, I'm trying to get my y term by itself. I've got -20 times y. So I'm going to divide every single thing, every single term by -20. The -20s cancel, and I get y, which I wanted. I wanted y all by itself. 40 divided by -20 is -2. And then again, I'm not going to write my x plus 1 squared divided by negative 20. I don't want it that way. I want to write it instead as something times x plus 1 squared. So instead of dividing by negative 20, I'm going to multiply by the reciprocal. That's negative 1 over 20 times x plus 1 squared. So this is another example, just like the last one. So I want to take a moment and talk a little bit about multiplying by the reciprocal, because I think sometimes students, I've noticed, had trouble with that. So let's go to the next page. The next page has a problem that's been worked out for us. They start by stating the problem up here. They state that the focus is 1, 4. And they state that the directrix is y equals 0. So then they write the equation. This is my new equation, x minus a squared plus y minus b squared equals y minus k squared. And so now they're solving it. They're solving it to get it into the form of y equals. And you can see all of their steps. I want to focus on this step right here. This is the step where you would divide every term by negative 8. So you would divide this step by negative 8, this step by negative 8, and this step by negative 8. So let me rewrite it out here so it's a little bigger and I can write on it. So I want to talk about a few things. First of all, negative 8 divided by negative 8 do cancel. So I get just y equals. Lovely, that's what I want. Let me come over here and talk about this first. Negative 16 divided by negative 8. A negative divided by a negative is a positive. So I know my answer is positive, and 16 divided by 8 is 2. So this is plus 2. So now I want to talk about this. Again, I have a negative divided by a negative, so I know my answer is going to be positive. But what I have here is something divided by 8. So if I could go to the top of the page, let's just pretend for a moment that I have just an x divided by 8. In algebra, at some point, middle school or somewhere, we were taught that dividing by a number was the same thing as multiplying by the reciprocal. So this is the same thing as 1/8 times x. Dividing by 8 or multiplying by 1 over 8, that's the reciprocal, is the same thing. Let me show it to you with like numbers. If I had 8 divided by 2, we all know that that's 4. Great. But I want to show you that instead of dividing 8 by 2, I could multiply 8 by the reciprocal of 2. That's 1/2 times 8. We also know that 1/2 times 8 is also 4. That's because you can either divide by a number or you could multiply by the reciprocal. And if I could erase this, another place where we've seen this skill is when we did fractions in middle school. For example, if I had 1/2 divided by 2/3, we never divided by a fraction. We multiplied by the reciprocal. So we rewrote this as 1/2 times, and instead of dividing by 2/3, I multiplied by the reciprocal 3/2, and I would have got 3/4 for my answer. So down here, instead of dividing by 8, coming back to my problem, I'm going to multiply by 1 over 8. That's me multiplying by the reciprocal instead of dividing by 8. It's just the way we write it, because now it's in this form, this y equals a times x minus h squared plus k form. So I know that my vertex of this one would be at 1, 2. I've got to think the opposite with the number in the parentheses. 1, 2. And I know that my a value, so that was my vertex, my a value is 1/8. The a value I don't believe was discussed last year in algebra, but basically if it's a fraction between 0 and 1, it just tells you that my parabola is wider. And if you look up at the picture, you can see the vertex is at 1, 2, right here, you guys, that's my vertex. And the parabola does look wider, and that would be what the function of the 1/8. So this would be the information you get from the vertex form, which is very useful.